there's EVT, DVT, PVT for like hundreds of subsystems that each need to like go together and meld into like a working plane.
I think about these three phases like works like, looks like, builds like. So the first one is it does the thing. The second one is it looks like the thing and we're getting close to how it gets made. And then the third one is this how we're going to build the thing?
I love that you said it that way. Like, what does that entail though?
Right. Hello and welcome to the Open Hardware Manufacturing Podcast, the podcast about making open source hardware. My name is Stephen Haas.
And I'm Lucian Chaput.
And today we're talking about PVT, EVT, and DVT.
Wait. What are those?
We still don't know what we're going to call this episode that doesn't sound like just a cat walking on a keyboard, but it's the three general phases of taking a product into NPI, new product introduction, going from like bare bones experiment to something that you put out the door.
You could conceivably make more of.
Yes. for the sake of making a lot of them, ideally.
Yeah.
And how we look at this, how the industry looks at this, how gray it kind of is, and how it's just nice to have a structure for thinking about explicit separate builds or, different stages you are in your product development.
Yeah, and if nothing else, this is a great framework for you and your engineering team to consider product release cycles.
Yep. Yeah. Even if the way that we recommend doing it is like completely off base for your scale or product, like it's a good thing to look into and pursue as a broad structure to kind of keep things organized.
Yeah, I completely agree.
Yep. All right.
Let's do it. All right. So like at the top of it all is product validation. That's the whole point of why we try to bring things to market in a framework of DVT, EVT, PVT. Product validation is important because you want to make sure you're building the right thing. You want to make sure what you're making meets the metrics laid out in your PRD. If you didn't do that, it's lunacy.
And if you haven't listened to the PRD episode, go listen to the PRD episode. For those that haven't, a PRD is your product requirement document, which outlines what your thing needs to do to make it viable to sell. Is it actually going to solve a problem for people? Is it going to be worthwhile to build for the money that you make doing it? Blah, 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 blah. You have to hit this PRD. That's your homework. That's your assignment of what you need to make here. So validation is making sure you did your homework correctly.
Yeah, and that can mean so many different things, but there's like catching design flaws, manufacturing issues, and like any possible risk, laying out any possible thing that could go wrong when you make your product, when the components for it are made at sub-manufacturers. You want to validate every possible concern you can think of and then some. Yep,
exactly. And that's why it's good to actually go through this process of building them and testing them, because as much as you might think, oh, I'll make an explicit test to check and make sure that the bloogity blurp moves the speed I expect it to in your product or whatever it is, that's fine that you're now thinking about that test. But there are a bunch of things that you don't even know yet could fail. And you need to just go through the experience. You need some like empirical user testing as well. You need to use the darn thing to know that for sure as well, because there's things you're going to miss. You're not going to be able to check every explicit test.
Yeah. And this is definitely another one of those topics where like people get a master's degree in it.
Yeah. Yeah.
There's statistical processes for doing validation. There's so much more that could be said here.
Yep. And you know what? I think we do have it on our list. We should do a whole episode on validation. I think it's been the queue for a minute. This is more about the structure around which you do your validation. How do you structure your team and organize everything when you're going through the product dev. But we should do a whole episode on that at some point.
Yeah, I think it's becoming overdue.
Yep, for sure.
We got to keep making these out of order.
We really did not do these in order. These are we should reorder all the episodes based on the order that I don't mean Mitchell gives me this crazy look of like, Steven, I don't want to have to rearrange the episodes. I just mean we just release an order of the episodes of like what order to listen to them in.
Oh.
Yeah. I don't even know if that exists because a lot of these happen concurrently,
Make a weird table of contents.
But anyway, so what are these three things? What are these three stages?
So the first one is engineering, validation, and test. Or some people say engineering, validation, and testing.
Yep.
Then there's design, validation, and test, followed by production, validation, and test.
Yep. And engineering, design, production.
Yep. The three of these are 3 layers of a weird ice cream sandwich. You shouldn't do one without the other.
Yep.
They go in sequential order. One starts and the next begins. I think of it as like a baton pass than a race to bring your product to market.
Yep. And this is something that, Lucian and I both worked at Form Labs. You were way more involved in like the NPI process at Form Labs than I was. So you have a different view of it. But I think of each one of these things as being like, manufacturing, mechanical engineering, electrical engineering, software, all working together to hand off certain parts of this integration, validation, testing, all of those things all kind of work in concert together for each one of these eras. And some have overlap and some do not. So we'll start with the engineering validation test, which is the first one.
Mm-hmm.
So engineering validation test is, the way that I think about this is like, it's just checking to prove the engineering approach of what you're doing and of the product. Does it do the thing? That's the whole point, is like, does it actually check the boxes here of what you're trying to accomplish? So it may not look like the final thing. It may be hard to make, but that's fine. Like, what you're really doing here is checking to make sure that you're going to be able to hit the spec in your PRD. What this looks like is a lot of prototyping and running quick back of the napkin math checks to see if it's actually hitting your metrics. So as we go through this, I'll reference a lot of like what we did for feeders, because we went through, I think, was this the first time we actually formally went through EVT, DVT, PVT for a product? I think it was feeders.
Yeah, definitely.
Yeah.
So it was fun to be a little bit more formal about it.
It was, and it was really helpful. So when we had our EVT for this, our metric was hitting a 402 accuracy for feeding. So from the beginning, I had a whole bunch of different ways that I was like, maybe we do it this way. Maybe we design the feeder this way. It was about what approach is going to give us the best accuracy. So the whole time that I'm putting this whole thing together, we're checking to see is it likely we can hit a 402 accuracy with this whole thing? If you're planning on getting stuff injection molded, this is a great time for 3D printed parts as well. If you're going through quick iteration and you're just trying to gut check whether or not an approach is going to work, you're not cutting a mold. You really, that's not happening.
Yeah. Don't make tooling for this.
So at Form Labs, a lot like, instead of getting things injection molded, they would actually print SLS parts. Huge.
Yeah, they were nuts.
They were like, some of them looked like sleds. Like you could literally sled down a snowy hill with like the back of the Form 3 cover. So many of them were like SLS print. They're really cool.
It's this massive plastic part.
Yeah.
Just insanely cool as a 3D print.
Yeah. And you never sell that. That's not DFM. That's not how you do it. The shape was kind of DFM. Like it was like how it might be injection molded, but we weren't going to get it cut that way because what if there was a problem? What if there was a bug with the design? We didn't want to cut the mold yet.
Yeah, I think each EVT unit had thousands of dollars worth of 3D prints in it.
Yep. And still way cheaper than getting a mold cut.
Yeah.
Because that mold was $500,000 or something.
There's nothing more expensive than cutting the wrong mold.
Yeah. Yeah, exactly.
Yeah, there's nothing more expensive than having to cut it twice.
Yeah. Yep. Yeah. Yeah.
Just order those prints. That's the idiot tags.
Yeah. So that's a way you can kind of, you just need to see if it's going to do the thing roughly, like, are you getting close? Is your approach nicely validated? And like, are you hitting the metrics that you need? This is not an engineering prototype where things are really messy and all over the place. And like, that's probably more happening on a test bench to understand the theory of what you're trying to do. And, it doesn't look anything like what you're trying to do, but
yeah.
The
phrase in my head for this level of development is works like prototype.
Yeah.
It might not feel like it. It might not be identical to your final thing, but it should meet the functions and criteria of your PRD and it'll work like the real one should.
Yep. Yep. Absolutely.
I think it's fair to say like what this looks like at a facility is you have your manufacturing engineers and your mechanical engineers, the design engineers coming together to build a kit of parts on a table. Like this is not setting up a clandestine operation and pretending you have a factory floor. It's just
right.
You put all the parts on a table and all relevant parties come together and just try assembling the thing.
Mm-hmm.
I probably wouldn't bother writing SOPs except for like advanced assembly techniques that took a lot of R&D to figure out.
Yep.
But like this is a time where I think you just put it together with your buds and you figure out what's rough about it.
Yep.
You'll learn so much in EVT.
Right. Yeah. Which informs the other stages and what you need to change moving forward because you are building it just with a bunch of buds on a workbench,
Mm-hmm.
Yep.
And like towards the end of EVT, a great thing is that you'll have some like finished prototypes in hand and you can do functional testing.
Mm-hmm.
That's so valuable. It's where you get a chance to see like, hey, did this linear axis move the right way? Is it smart of me to use a lead screw here instead of a ball screw? Like
right.
It's a real chance to get the whole owl drawn out. See what it looks like.
Yes.
See if it looks the way you need it to.
Mm-hmm. And that's the whole point of doing all of these stages is like trying to test the darn thing. You're trying to see if it's going to do it. So like once you have one that's not a prototype, but it's like put together, you can actually kind of dive into seeing if it does all those things, hitting all your metrics in the PRD.
Yeah. I remember like when we talk about 3D printers during EVT, it's always super fascinating because it's a really precise system and you're balancing like ease of assembly with cost of the machine. So sometimes it's like, this really expensive component does what we need to, but this EVT unit was built with a lower end like linear motion part, and this is also where like you're looking to see like, is that good enough? Like,
so at this point in like EVT, for example, is that where you would swap in like different like vendor parts? So like, because I think as we're going through this, I'm noticing that we think about this very differently, which is very interesting because I think a lot of where this comes from is your exposure at Form Labs. And I had so little of this at Form Labs. So the way I think about these 3 stages is very much how we did it with feeders. And I don't think that's how most other people do it. So you're talking about like trying out a different vendor, higher quality thing in EVT. Are you noticing like at Form Labs, for example, or do you think it's standard that people are like swapping out different like supplier parts and testing that?
Oh, I think EVT has no loyalty to your given supply chain. The supply chain probably isn't even established for a product at this point. And like a large company doing an EVT.
Sure.
You're using prototype vendors.
Okay.
And then it's your job of your production suppliers to match the equivalent quality of what you used in prototyping.
I see.
And maybe even dial down quality where you understand you could through like communicated GD&T,
right?
Like drawings.
Sure. Which is kind of what we did for feeders because we had a random off the shelf motor that wasn't from our supplier with the right PCB and everything. It was like a little hack together to get it to do the thing and validate it. So kind of like that, right?
Yeah.
Okay.
No, I remember the buyers for the Form Labs team working with the engineers buying like 4 different types of linear rod to see if it was
for EVT.
Yeah, just to have them all on the table as options and see like what was good enough.
Right. Okay, so before EVT, you've made a thing that like already kind of does the thing. You've already kind of gotten a thing that's like, oh, it looks like this will print. It looks like this will pick and place parts, whatever. EVT is it really coming together for the first time fully and starting to test out different vendors.
Yeah.
Okay. I so have a different perspective on this from feeders than this. So it's good. It's good we're hashing through this.
And this is also like, to me, it's kind of vibes based because every company in the world is going to do this differently.
Right.
If you try to read this as gospel, you're going to be wrong.
Yep.
Outside of Opulo.
Yeah.
But there's a lot to take away. And it's all key concepts, I think.
Mm-hmm.
Yeah. Ultimately, EVT, you're creating something that you can mechanically and electrically assess.
Yep.
The boards probably aren't ready for mass production. Again, nothing injection molded, but you're putting it all together and seeing like, oh, the screw here, horrible idea.
Sure.
This PCB should not be mounted to these 4 pieces of sheet metal.
Right.
Maybe we move that.
Sure.
EVT is a good chance. I think of it as like you wrote your doc and you turned on spell check for the first time.
Sure. Okay. But really from EVT onward, it should only really be tweaks.
Yeah. I would agree with that. Like the PRD shouldn't be changed because of what you learned in EVT.
That I fundamentally agree with. I don't think really the PRD should ever change. Not because of what you learn as you go. If you realize you can't hit the PRD, you don't make the product.
Yeah, exactly.
Because there's no reason to if it's not going to be a thing that's useful to people. So, okay, that's it. Yeah, because I have a totally different view on this then because I was imagining EVT as like kind of more like the engineering prototype. I think we kind of collapsed a bunch of stages together into each one of the builds that we did that we called EVT, but it really wasn't. Yeah. Okay. That makes a lot more sense to me now. That's good context.
And there's phases for like engineering prototype development. I just don't know them by name.
Yeah.
Like there's entire methodologies and books. And again, master's degrees you can get on being the PM to this stuff.
Isn't it just F around, find out, repeat?
Yeah. Keep doing that.
I think that's how it goes. Okay, cool.
F in FO. No, FAFO.
Yeah, FAFO. FAFO repeat. And then also performance benchmarking. So like, and this is kind of what we were just talking about is like, you're coming up with numbers. You're coming up with hard data, like results of how your EVT unit is performing.
Mm-hmm.
Yeah.
This might even be a chance if you have a big enough team where the product team gets involved. It's their first chance to see what like an assembled production prototype, I'm going to call it, looks like from what came out of EVT.
Right.
Their chance to go, hey, is it too loud? Does it move nicely?
Right. Yeah.
Does the synthesizer make the right tone?
Right. There might not be a line on your PRD of cannot leak hydrogen gas, but if it does that, you should probably notice. So yeah, good time to catch those things.
I remember
probably earlier than that though.
One of my favorite anecdotes from Form Labs of EVT was the industrial designers getting pulled down into the like engineering floor to see if their designs on like pen and paper felt the right way. I thought it was so cool. Like I have to imagine how cathartic it was for them to see their things IRL like that first time.
No kidding.
I'm sure they were involved sooner than like finished assembly, but
Right.
like this is the time where your industrial designers even check to see if they spelled things right. Did this latch mechanism feel the right way in the hand?
Right.
Is the idea of a latch here a good idea?
Right.
Like, what's the UX? You can finally see, like, is my idea of the UX to this product going to be the right thing?
Right. Yeah, that's true. The first kind of watching it come together.
Yeah.
Yeah.
And I even remember, too, the jankiest EVT units were then immediately handed to the embedded team so they could start, like, porting a previous generation printer's firmware to the next one.
Right.
These units will live on for months or years, depending on your release cycles.
Sure. Yeah.
Like they're really laying the foundation for like what comes next.
Right. It's the first opportunity for a lot of people at the company to kind of sink their teeth in and kind of start engaging with it in a physical way instead of a metaphorical way, a theoretical way, I should say.
Yeah, like if you're writing firmware for like a next generation printer, for example, like you need to have it in hand. You can, you can make a lot of GitHub issues, but there's probably nothing better than having one on your desk.
Right. That firmware is pretty hopes and dreams until, it's probably just a bare PCB on the desk, but like so much of what makes it work well is like actually testing it fully integrated. So much of that is the integration.
Yeah. And there was a whole team for Form Labs at that.
Yeah. Yes, there was.
Rip.
Yep. And so when we were in EVT for feeders and we were going through, what was it? Oh yeah. I made a huge mistake with how the slots were set up, where pins would connect on certain pads where they shouldn't, and it would cause a short, and it was a whole thing. So when we got the new boards in, we got quick turn boards, we just slapped them on the Lumen and I loaded into the new job and I just went through and populated another batch. I think I only ever made like 3 at a time or something. I think I only had 3 on the Lumen because I just needed enough to check. I just needed to spin up a couple of them. So I would get the new board in as soon as they came in, dropped them on, ran a job, and then I could immediately test there. So the Lumen is actually really handy during EVT with feeders, which is so meta. But it was really nice to just be able to drop in the new board, make a new version, check to see if that one thing, any showstoppers, right? Because like in your scenario with the Form 3, when I was going out to the team, if there's a showstopper where like, if the Z jogs to, 10 millimeters, the whole machine shuts down, like, no one's getting any useful work done on that unit. You need another pass at that thing quick. So like, it's nice for that kind of thing.
Yeah. EVT is definitely the point in time where you should do it in-house with like a highly reactive team, just ready to put out a fire as the minute it arrives. Like your goal is to get something working out of it. And if your schedule runs long for that to happen, it's your job to react accordingly.
Right. Yep.
And that's why the Lumen and like for feeders is super handy because we just go remake the boards.
Yeah.
Something wrong with them.
Yep. Yeah, exactly. Yep.
Yeah, that's EVT. I'm sure there's a lot more could be said, but it as an outcome for EVT, your goal is to have a functioning prototype with validated engineering. Your goal is not to have something optimized for mass production.
Yeah.
That would be a massive distraction.
Right.
That's a non-goal.
This is like, like at this point, it's not about making a lot of them. Like it feels more like a kit than anything else, not a finished thing. Cause you're not planning on making a lot of them this way. You are eventually, but the way that you've put things together here, it's about just making a few that you have in-house. And that's the most important priority for this.
And I think a lot of people only go this far, especially if they're selling something as like a kit.
Yeah. I mean, like it does the thing, you put it together. It depends on how you're selling it, right? Like, does it work out of the box? There you go. Or do you have to put the thing together? EVT's kind of up to that. Yeah. In some ways, I think.
Does it meet the goal? Good enough.
Cool.
Yeah.
Yep. There we go. Ship it.
It's important to go so much further past that. And like we said earlier, ideally the output of EVT is like a product in hand that's good enough for your other teams to get some useful mileage out of it and like let them sit with it until you have units from the next like production batch. Like sometimes the units here go straight to lifetime testing.
Yep.
Critical.
Yep. Yeah, absolutely critical. That's a huge part of it.
Yeah. Another incredibly important outcome of EVT is just identifying major design flaws early. And this is where like, if there's a design flaw you found in EVT that makes it so PRD is hard to meet, repeat.
Yeah. Slam on the brakes.
Yeah, exactly. Yeah. It is not the right attitude to say, oh, we will solve that design issue in EVT.
Yeah.
You haven't left EVT yet if there's a major design flaw that requires being addressed.
Right. Like the problems you're solving going into DVT and PVT, design and production validation testing, are not systemic architectural issues. They're not problems with how the thing functions. They're like this bolt isn't where it should be. This could be better. This is hard to assemble, blah, 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 blah. This finish doesn't come out right. It's about scaling into making a lot of them more than anything else.
Yeah. If we were writing a book, EVT would be your rough draft. And like past that, you're not adding more chapters. Like,
right. You've written the whole book.
yeah.
And you know the story is like not crap.
Yeah, you're not adding a character.
Yeah. You're not adding characters. You're not adding any little extra whistles and doodads on at that point. Like you've written the book.
Yeah.
It's just not great. You just need to tweak it and make it better. And especially when it goes to production, when it goes out to a lot of people, how does it land there better?
Mm-hmm.
Yeah.
And like poop rolls downhill. Again, just to reiterate, because it's so important. You do not want to save your problems for the future.
Wait, hold, pump the brakes. What did you say? Poop rolls downhill?
Yeah.
Hey, are you replacing poop for another word that means poop that we can't say on the podcast? Yeah, that's going to be a funny bleep. What is that a phrase?
You've never heard it?
What does it mean?
It means like problems just cascade and keep going down.
Oh, yeah. Okay. Yeah. So, yeah. Poop rolls downhill into DVT and PVT.
Yeah.
Yeah.
So you just want to like put a Band-Aid on all the bleeding as soon as you can.
Yeah.
Like do not let exacerbate your issues by ignoring them, procrastinating on them.
Barreling through and being like, we'll fix it in the next build.
Yeah. Fix it in post?
No, there's no such thing. Post is now. Post is real life still.
We live in the present.
We live in the present.
I think another important outcome of EVT is from like a manufacturing engineering perspective, an idea of what fixtures and toolings you might want the next time you sit down to build a batch of your product. Because like you don't know what you don't know here. Like, only when you sit down to build something for the first time, you really have an idea of what jigs you're going to need. You wouldn't want to overthink it ahead of time, I feel like.
Yeah, actually trying to build the thing is going to be the most informative on what you need. Yep.
And like this is why 3D printing is great. You can just quickly whip something up next time you go at it.
Yep. Yeah, for sure.
There's a little bit of a hedge here because we're saying EVT is built around prototype parts. Sometimes there's going to be issues that are resolved by switching to like something that's tooled, injection molded, made out of die cast metal instead of a 3D print.
Yeah.
Those are the types of issues where it's probably okay to assume they get resolved in subsequent DVT builds.
Right.
You're going to want to keep a really close eye on those.
Yep.
But if you're going to let any issues persist into your next like production batch, that's the type of thing I'd think to look for. Or like a software issue.
That's what I was thinking is like, if there's a firmware thing where like, oh, this sensor reports the wrong value or whatever, but you know that when it reports the right value, you'll be able to do this process correctly. Okay. Assume that gets fixed in software, but you have to be real careful and choosy about which one of those things you're like, all right, we'll allow it moving into DVT.
Yeah. At Form Labs, this was a really challenging junction because there was the mechanical engineers, the print process engineers, and the manufacturing engineers. There was still like the idea of running let's use the Form 3, we have experience in it. They were still figuring out how to make it print well. Like what are the tuning settings and optimization settings? Like what are the mechanical tolerances the assembly process needs to meet? And like the manufacturing engineers just want a number of like these parts need to be this amount of parallel.
Right.
The mechanical engineers need to know what to put on the drawing.
Yep.
The print process engineers didn't really know what to put yet because they're waiting for their EVT units to come in and see how they print.
Right.
So it was like there's 3 chickens and 3 eggs.
Sure, yeah. So what's the solve there then? Is there like during, engineering prototyping, is there a jig that allows you to accurately define the parallelism? Let's just say it's parallel plates or whatever. These parallelism, and you can adjust it, and like that's what print process is using to test their settings. Is that's how they set the spec. Like the spec should have been set before they moved on to EVT. Then
I'd say that's the most like optimal thing.
Yeah,
but it was tough for them because they're working with like 3D printed versions of the resin tank.
Yeah.
And like so much stuff changed when they switched to it being injection molded.
Right.
Or like the build plate. I think early on it was a CNC machine part, but eventually it became an extrusion and like the flatness is going to vary.
Yep.
So like there's certain types of metrics like that that will need to be reassessed when you switch to like a tooled part. Sure. And like a really good approach for handling that is to tool some parts that are critical to quality early.
Okay.
And like engineer around those from then on.
Right. Yeah, for sure.
That's like the handiest tool there. Like I think the resin tank was one of the first things they tooled.
Yeah, that makes sense because it was such a dependency on other things.
The printer was built out from the tank. Basically.
Right. Yeah. Makes sense.
Yeah. DVT is the next section we're going to talk about, and that's design validation and testing again. And that one's like my favorite because This is where you go up to bat that second time.
Yep.
You've learned from the mistakes in EVT and you've done your best to address them.
Mm.
This is the first time you're like showing your essay to the teacher.
This is your first draft you submit.
Yeah.
Okay.
So like the purpose of the EVT to me and many others, I think, is to ensure that a product is ready for production, both in design and manufacturability. This is where you think about DFM or DFAM if there's printing involved.
Yep. Yeah.
It might not necessarily be your final supply chain, and that's okay. The industry usually agrees it's near final materials and near final manufacturing processes.
Okay.
So like maybe something is a urethane cast instead of an injection mold, but it's not some aluminum like 1-to-1 copy of a plastic part.
Sure. So this is still like maybe the methodology of making the part is a little different, but like the materiality might be close. Like you said, urethane casting versus injection molding.
Mm-hmm.
Even at DVT, it'd be okay to not do the final manufacturing process.
It's preferable.
Yeah, sure. But like if your first shot of a mold is around PVT, you still have time in PVT, which is the next one, like down the road, to be able to iterate a little bit. So it's okay if it's not really the final method quite yet.
I think it completely depends on like what you're making and what you've identified as a risk.
Right. Yeah. Because maybe you don't give a rip. Maybe this thing's going to be easy to injection mold. It'll take me, 2 hours to get the drawing together. Our vendor's going to handle it. It's going to be fine. It's not a critical problem. That happens at PVT. We don't care.
It's also fair to say like the more injection molding you can put in this, the better.
Yeah.
And again, it's important to reiterate here. If there's a part in the machine or like your product that's super critical to quality or like high complexity, this is where it probably is important to get it tooled and get your hands on like an injection molded version of that thing and use it in your DVT units.
Right. Yeah. It depends on how important it is. Like I know with Form 4, they have this wacky lens thing that they use to distribute the light like nice and evenly from in the LED array they have underneath. And I think that was like one of the very first things they started working on. And they had samples of that thing injection molded from like really, really, really early on. Mm-hmm. Like that was an or they had some really expensive process that got it made like it would be injection molded. Like that was way brought up in scale because it was necessary for doing all the testing for the rest of the thing. Mm-hmm. So, and it's also a complicated thing to get made. So yeah, I think that one probably was pretty heftily injection molded around DVT, if not EVT.
Yeah.
Yeah.
And like at a very high level, I think of DVT. Steven, tell me if you agree. I think of it as like a looks like unit or maybe even a prototype looks like it. Mm-hmm. It looks like the thing. It works like the thing.
Yep.
It might not be built from the final production sources, but a DVT unit might look identical from the outside to a production unit.
Sure.
Or like your goal is to make it look as identical as possible.
To production. Yep. Yeah. No, I agree. Yeah. First is works like, then looks like. Mm-hmm. Yep. I think so.
From that point, we can talk about like the key activities of a design validation and test build. Mm-hmm. And like we said up top, like DFM or design for manufacturing optimization is paramount to this. Like it is important to do things that scale. Mm-hmm. And you have to really emphasize that the importance of DFM in a product.
Yep. Yeah.
The difference between like arts and crafts and like manufactured products is how well they go together. That's how I think of it, at least.
Yep. And just like with injection molding, the earlier you think about this, the easier it's going to be for later passes. It's tough because like if you're an EVT and you're just trying to get the back cover on the printer so the thermals are normal and like representative, you might not want to spend a lot of time getting your draft angles perfect for injection molding. That might be a little too early of an optimization because then you might need to change where a rib goes on the part. And then you have to redo all this draft angle crapola and like, okay, maybe that's kind of a waste of time. So maybe you wait a little bit to do it. But the earlier you do it, the earlier you're thinking about the idea of draft angles and thinking about the way it might be injection molded. And you might catch and realize, oh crap, we can't even injection mold this part because of XYZ.
Yeah.
I didn't think about this undercut or whatever. So the earlier you are thinking about that kind of thing, the easier it gets to catch them as you go along. So it's a similar kind of thing of like, where do you happen to draw the line? I'd say everything should have a DFM pass by DVT. Maybe you've thought about it in EVT already, but everything has a path towards, I know how this is going to be made, and it's as close as reasonably possible to how it would be made in production in DVT. Is that fair to say?
I agree with that.
Okay.
There's companies with very strange workworkflows. And like using a contract manufacturer that offers like engineering services can totally break these notions.
True, yeah.
Like there's a large foam dart blaster company they just send their prototype to a CM and they get back like production samples.
That's crazy.
Like
just like a random bodged together thing. And they're like, make this into a production thing. And then another organization does that.
An engineer at like the American HQ for this blaster company does not think about draft angles.
That's wild.
So like, it's to say, lean on the expertise of your vendors. And if there's key risks around like core technologies, like get that stuff tooled early and work in hand with your like suppliers, because they're going to tell you if something's doable or not.
So do you think prepping for a DVT build would be the time that, like, let's say, you know, we're going through Lumen V4 and let's say there's injection molded parts in it.
Mm-hmm.
Before our DVT build, you'd start talking about getting an injection molded part made? Like, when do you think that conversation gets broached of like, would it be during EVT or like, hey, I might want this part molded, just letting you know, here's the rough shape. And then they start thinking about it. And then after you feel good about it after EVT tests and you're going into DVT, you're like, please cut the mold. I'd like this part now. And then off they go and they get the part made. Does it feel like that? Maybe. I know it depends. I'm asking you to put a lot of like, here's a rule around a very gooey, squishy thing.
Offline before we recorded, we were talking about whether or not like, is there a pause between these phases or not?
Right. Yeah.
Does the baton go immediately from EVT to DVT, or is there a month-long break where learnings are applied and looked into?
Right.
I don't think there's a clean cut rule here.
Yeah. Yeah.
Like at the end of EVT, you might go, that sucked. We didn't like how that ended up being. We're going to take a couple months to figure out how we want to approach it before we even try to make these again in DVT.
Yeah.
I'm of the camp of they don't go back to back.
There's a big delay.
If needed.
There can be. They don't have to go hand in hand. Okay.
So like, if like, let's say there's some complicated injection molded part and you're worried about it and you've just finished EVT with the printed version of it, you should probably take a couple months to talk to your vendors and figure out how you're making it and get some like aluminum molds cut so you have it in hand for DVT. That's probably how I would play it.
Okay. Interesting.
Because like the goal is to go through the DFM of everything, and a lot of the times like most people listening don't own an injection molding machine. So they're going to get a lot of feedback from their suppliers on how to do it. And like, you just need to get told what to do there. Like the DFM for injection molded parts is kind of prescribed to you by your vendors working in hand with like a company's internal design engineers.
Right. And that takes time.
Yeah.
Yeah. Actually building a DVT unit takes a day. Ideally, you know, like it's a bunch of people, like you said, I meant EVT, but you know what I mean? Like you lay everything out, you put them together, you get your machine, maybe 2 days or whatever. That's a quick build. You might need to make a lot of them, but like a lot of it is like what you do with the stuff you learn from these eras effectively. Yeah. Okay.
Yeah. Vibes.
A lot of vibes. Yeah.
Yeah. And I'm sure at Apple, it's like super militant. We're coming from like a tech company background, a really small team.
Yep. Yeah. We do it very differently from all this. Yeah. This is so not at all how I would have written all this stuff out, because I did not have this exposure to formulas. And for me, I've glommed a lot of these parts together, and we don't have nearly the same restrictions because we 3D print so much stuff in house. We have the Lumen to iterate through boards and building boards on the Lumen in production. It's like, we have so many fewer shackles in terms of scope and time. We could just kind of whip through a lot of stuff. So our scope is very different, I think, in how we do things here. But yeah, it's interesting to hear about how different it actually is of how we do this from like Form Labs putting out a printer.
Mm-hmm.
Yeah.
And that's like the boon of in-house manufacturing. A scrappier team can be so much more productive with in-house prototyping and in-house product development than like being reliant on a overseas CM.
Right. Yeah. There isn't the time shifts of staying up to communicate. There are parts getting shipped back and forth. Like we just do it all here.
Mm-hmm.
Pretty nice.
For sure.
Mm-hmm.
In DVT, like we said, everything's gone for DFM. Mm-hmm. And DFM is inclusive of like the process itself. Mm-hmm. So like DVT is the time where like we are hypercritical of the production process, and like you probably begin drafting the SOP for like what you would follow in like subsequent batches of like product development.
Mm-hmm.
I think this is a great point for the team behind the DVT to pull in like skilled production engineers and assembly technicians and like get their feedback on the assembly process.
Mm-hmm.
The DVT units are not where you'd be pulling in like unskilled, inexperienced labor. You want people that understand the engineering intent,
right?
Working to put together these units.
Sure. And these are still made in-house, right? Like we're not going to a CM yet? Because that was one of my next questions is like, when does a CM come into all this? Or contract manufacturer, like a factory?
That's again, it's going to depend.
Yeah.
If this is a foot pedal with a button on top and a circuit board for guitars, I could probably do this abroad or outsource. I think there's a lot of value doing DVT internally.
Mm-hmm.
Like even like if we bully Apple, they do this internally. They'll have a pilot line at their HQ and a pre-production line at their HQ. And they probably work with their vendor and have like a copy of it set up at their facility, and they probably both do their own and share feedback.
That's so cool.
Yeah, it's really intense.
You're saying there's like a little micro iPhone line at One Infinite Loop in Cupertino?
Yeah, 100%.
That's so sick.
Yeah.
That's so cool. The emergency backup production line.
Oh God, it makes like 2 phones a day. I'm sure it could probably make a bunch.
One for Tim Apple.
But yeah, DVT, it's a critical juncture for refining your processes and imagining how they could scale and seeing what doesn't scale.
Mm-hmm.
Like maybe EVT identified the fact that a glue needs to dry for a long time, and you try that out and you go, oh, actually this sucks. And because it sucks in PVT, I'm going to have to make a glue drying rack.
Right.
That's blah, blah, blah.
Sure. Yeah. And because you are also like, each one of these eras is like, you're building a number of units, you know, like in DVT, EVT, you might build 10 units, you know, again, it greatly depends on your scale, but like you might build a handful, enough for each like person that needs to be involved and have hardware can get some and mess around with them. And then DVT, you're building quite a bit more, you know? So like if there is a glue drying process, you can try it every time you build them. It's like, okay, cool. This didn't work for this build. This one did for this one. Let me try it this way. Every time you go through the process, you're kind of understanding how it best goes together when you build all of them too. So like, it's not just one pass at it. Like every time you build one, you get another pass.
Yeah.
Yeah.
No, it's super handy.
Yeah.
And if I hadn't said it before, I think it's also a great point at which you can like test prototypes of assembly equipment, jigs and fixtures.
Right.
You might not have had them all figured out, but I'm sure during EVT, you'd probably have realized which ones you are non-optional, non-negotiable, and you bust out some sample ones.
Sure. Yeah, absolutely. Yeah, jigs along with this are weird because so much of your validation could be dependent on the jig accuracy and like the fact the jig exists and all these other things. Like that might be necessary for a lot of the validation tests that you're running throughout the course of all this kind of stuff.
Yeah, this gets really complicated, and depending on the complexity of the product, you can make a decent argument that the jig should be developed before the product exists.
Right.
Like, let's say we need to measure the parallelism of like and perpendicularity of 3 mating parts altogether.
Yeah.
I have a lot of trauma behind that example. You need to have like an agreement of sorts between all the teams about like what's okay, how to measure it.
Sure.
And that should be in place before you go to build things.
Yeah, absolutely. That needs to be strictly written down somewhere already and all agreed upon.
Yeah.
Yep.
There's a lot of people have this notion that the factory is 10 times more complicated than the product. Like making something is one thing, but to figure out how to make it at scale with the systems and processes and supply chain, it's 10 times more work.
Yep.
With a lot of product development, designing it's the easy part.
Yeah. Yeah. Bunny Huang has a line where he's like, when you make a product, you actually make 2 products. You make the product and you make the product that tests the product.
Yeah.
And he talks about it for like pogo pin jigs for testing PCBs, but like when it's a whole factory of a thing, it's like, oh man, there's a lot of those. There's a lot of quote unquote products that go into making that happen.
Yeah. It's an amazing symphony to watch.
Yeah. 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 It's cool.
Yeah. DVT is a good point at which you start thinking about like the system of it all and like this product's place in that factory.
Yep.
This is not highly structured.
It's a very goopy, like it's hard because it depends so much on your organization.
Yeah.
It depends on what your product is and how high risk it is. Like if you don't have a high risk product, and like you said, like your example of like a guitar pedal, great example. It's like, you know, the circuit works. You got to test the circuit. You put it in a box, you put a button on the box, you move on.
Yeah.
Like, you know, it's going to do the thing, right? That has a very different level of testing and procedural, like progress through figuring out how to make the thing than like a highly precise optical, like laser machine.
Yeah.
Like those are 2 fundamentally you shouldn't have the same process for putting those things out the door because they're different things. They need different stuff. So It's just so much of this is a big annoying. It depends.
Mm-hmm. I can't even fathom what it's like to go through this process for a car.
Oh my gosh. Yeah. I can't
thousands or maybe tens of thousands of components that come together.
Yeah.
And you have to make sure they all fit.
Yeah.
And talk to each other on a CAN bus.
Oh God. I cannot even imagine what that looks like.
Like, let's look at like, I don't know, a rocket ship, like Orion or like SLS, Selective Launch System, I think it stands for.
Yeah.
You still go through the same thing here.
Yeah.
Insane.
Crazy.
Yeah. And like the engineering is being developed by like 100 different companies and integrated together.
Oh, that makes me sweaty.
Yeah. Anytime someone criticizes a program like that, I'm just like, you do not understand.
Yeah.
Like there's EVT, DVT, PVT for like hundreds of subsystems that each need to like go together and meld into like a working plane.
Yep. And then they have to kiss and be reliable and safe. And then also, or EVT, DVT, PVT for those all together. I mean, like, it's just, there's so many layers to it.
Yeah.
There's a reason things take this long, you know? Yeah.
Yeah, it's a heady thing.
Yeah. And we'd like to thank this episode's sponsor, PCBWay. PCBWay is what we use for all of our prototype PCBs, which we use through every single one of these stages as we're going through doing quick iteration, trying to make sure that our boards are spinning up correctly and we're ready to move into the next phase of production, our next phase of NPI. From the time we submit the boards to the time we get them in-house can be under a week, and sometimes they've even caught silly mistakes that save us a ton of time when trying to get through all of our validation procedures. Thank you so much to PCBWay for sponsoring this episode.
Another really important key activity in DVT is just ensuring that the product you built still meets the lifetime requirements laid out in your PRD.
Yes.
So if you had done any evaluation of it in EVT, that's awesome. And that's a great benchmark to compare if your looks like unit matches or beats the measured characteristics of the EVT units.
Yep. To be able to run some of these tests on as close to production hardware as you can, so you know what the actual, because if you run a bunch of tests in EVT with like a bunch of random, maybe you do run it with, you know, linear rails from these three companies and you run a bunch of lifetime tests with EVT units and you see how those perform. And then maybe that informs what you get for DVT, or maybe it doesn't. And you just pick one of them that's cheaper and you see if it works. These tests really matter with the thing you're going to ship. It's good to know if you're trying out a bunch of them, maybe which one has, what's the best performance to cost ratio, XYZ, whatever. But you're really like double checking your work here and with a DVT unit is how I at least think about it.
I think of it the same way.
Okay.
And every company is going to be a little bit different here.
Yep. So all these things.
But it's about continually evaluating the quality of your unit to make sure you're continuously more and more ready for serial production. That's the goal of it all.
Yep.
Everything should be in the name of that.
Yep. As you get closer to the way that you choose to make many, many, many of these things, is that going to continue to fulfill what's on your PRD?
Mm-hmm. To recap, as like the outcome of DVT, it should be centered around having a finalized product that like meets all the expectations and requirements while being optimized for mass production. You've taken your swing at addressing any remaining design flaws before entering full production, and you feel good about it.
Yep.
And I think by the end of DVT as well, things should feel like they've stabilized around a design you could conceivably scale. That's another way to say it.
Yep. It's getting close to a wrapped up, buttoned up thing that is ready to be made. Yeah, you're right at the precipice of that.
And Steven and I here too, like it's important to say our experience in like a large team doing this was for printers that were amazingly complicated.
Yeah.
They were tens of different subsystems, like chemical, electrical, like optical, all
Thermal.
coming together to KISS. So many different types of engineering disciplines needed to meet to make this type of machine. So like there was a lot to it, and it took a lot of caution and a lot of hard hours to get this right. And it was a beautiful machine to watch like unfold.
It really was. It was so cool watching all these like SLS printed frames that were like kind of on half correct and like, you know, not quite where they needed to be, to like, then you'd start seeing, you know, all the DVT units come through and then they look a little nicer and then they have some urethane cast things and then you get to the PVT. It was very cool watching them progress.
Yeah, for sure.
Yeah.
So the next step is the PVT, production validation and test.
Yeah.
But there's a decent amount of stuff that probably needs to happen based off your learnings of DVT.
Yeah.
Because I consider it to be work that goes between these phases.
Yeah.
So like as an example, you need to make sure that the supply chain's set up now. Like this is injection molding time.
It's do it now or do it never. Like if you're going to get injection molded, now is the final opportunity.
Pretty much. Yeah. This is the point. And like, if you had tooled parts in use in DVT and you didn't like them, this is where you make your mold changes.
Yep.
PVT should be centered around making your final version of something.
Yep. It's almost like the practice run is how I think about it. It's like, it's the dress rehearsal for the show.
Yeah, exactly. Let's see what else should be done ahead of like even thinking about telling your CM or your factory floor at PVT starting. Like 100% supply chain set up.
Yep.
All parts tooled.
Yep.
If there's something not tooled yet, you better have a good reason.
Yep. Or you're not starting PVT yet.
Yeah.
PVT starts when everything's tooled. Yeah.
I think it even fair to say like an electrical engineer feels good about the schematic and circuitry and feels ready for the customers to be receiving products with that board.
Yep.
Like this is done changing stuff.
Yep. Yep.
If a capacitor is being changed, it's because Murata is cheaper and equivalent, not because we need more precision.
Yeah, it's a cost down thing, not a design thing. Yeah. That's a great quote. If a capacitor is being changed, it's because Murata is cheaper. Yeah. That's funny. Yeah.
That's it.
Yeah.
But like with that out of the way, I think we could explain a little bit about like the goals of PVT.
Yes.
And like per the literature, it's about verifying that a product can be mass produced effectively and at scale. It's a full shakedown of your production line, supply chain, and even now quality control systems.
Yes. The whole, not just the product, but all the products that wrap around the product.
Yeah. Is the machine that makes the machine ready to make more machines.
To make more machines.
Yeah.
I think about these three phases now that we've gotten to PVT. I think about it like works like, looks like, builds like.
Mm-hmm.
So the first one is it does the thing. The second one is it looks like the thing and we're getting close to how it gets made. And then the third one is this how we're going to build the thing at scale?
That's a great way to phrase it.
I like thinking about them in that structure.
100% agree. I love that you said it that way. Like, what does that entail though?
Right. Sure.
Like, as we kind of alluded to, pilot production run with final materials and processes.
Yep.
I think it's debatable depending on product complexity, team size, like whether or not this is taking place at like a contract manufacturer. Is it taking place on your production line? Ideally, it's taking place where the thing is made in serial production.
Yeah. So if you are going with a CM or a contract manufacturer, some factory you hire to build it, you're probably talking with them during DVT to prep to do a PVT build at their facility, assess how it goes, and then be able to launch into mass production. If you do choose to do a CM, does that sound right to you? Because for us, we are the production line. Yeah. So it's a little different. There really is no delineation there.
So ultimately, no matter where your product may be being built, PVT should be happening at that location.
Yeah.
Whether that's your basement with your prepared tables or at your chosen contract manufacturer in another country.
Right. Yeah.
This is where PVT should happen.
Yeah. It should be, you're pretending. It's a dress rehearsal. You're up on stage, dressed up in the outfit you will be on opening night. It's a show. You pretend like it's a show. You know, that's what dress rehearsal is. So as close as you can get.
Yeah. And for the actors in this dress rehearsal too, I think it should utilize the people that would be performing the real play. Just overstretch it.
Yeah.
You do not want engineers staffing the assembly workbench. You want to see how uninformed talent handles your SOPs when presented with them.
Yep.
And how they engage with the line you've built out.
Right.
Like, you haven't really done your job if you built out a system you can't walk away from, I feel like.
Right.
The SOPs need to be able to speak for you. The jigs and fixtures need to be self-evident or explained.
Yep.
The materials need to be present and accessible.
Right. And what's interesting about this is, like, I'm thinking as you're talking about all these things, that's no different from like a normal day of production. So in my mind, PVT is like just the first build off the line. Like, this is you starting the line, but everyone kind of agrees. Yeah, but we're not selling these, right? Yeah, but these are just for checking. But you're really trying it, like, because, you know, if there's a bug on our line here, and, you know, Adam comes over to us and he's like, hey, this jig is actually pretty hard to use for XYZ reason. That very well could have happened during a PVT build, but it can still continually happen throughout the rest of production. You can still fix bugs on the line throughout production. The PVT build is just the first, where you're going to catch most things.
I completely agree.
Yeah.
PVT units should be going into like customer saleable packaging.
Yeah.
Like, they should be in all parts customer saleable.
Yeah. Yeah.
And this is probably commonly where review units come from.
Yeah. I think that's probably a lot of it is PVT stuff.
But this is kind of interesting. PVT, like, the factory is not a black box. There's still engineers should be observing the processes and making sure things are going right. Mm-hmm. And that's probably why people say review units are like always better and like not representative, because there's still engineering oversight to make sure the play was conducted the right way.
Right.
It's not the kids off to their own.
Sure. Exactly. So yeah. And when, like you said, when you're kind of trying to set up the machine that builds the machine, that's every part of it. Like, it goes into customer packaging. Is the heat sealer machine working correctly? Does it happen to make the film cling to the display that makes it not work? Like, all these kinds of little things are where they come out. And that also includes all the testing software. So, you know, at Form Labs, there's a whole team around this. Here, there's a whole team around this. It's being Lucian.
Us in Google Sheets.
Us in Google Sheets, baby. That's all we need. And Python. That's all I need. And a Linux laptop. But, you know, when you're getting to this point, ideally, you've already built out some amount of stuff to do a lot of your validation testing, because you've been having to test if these things work this whole time through this entire NPI process. But kind of baking it and distilling it down into a thing that is ready for an operator to use to test these things. It's logging the data in a way that your customer support or, your production line is able to assess and look at all the log data. That's where these systems come through. So, a factory can have an entire system for like measuring things, logging data, making sure that things get, measured and logged and QC'd correctly. We have our own system. We wrote our own software that does all this stuff. So, building out this whole system is yet another product. It's not just the jigs, but it's like, if you choose to do all this logging, you choose to, do all these QC checks and like a way of ensuring that all this stuff happens, that needs to be built too. Mm-hmm. And ideally it's coming from little scripts and tests you've already been using for validation, just being formalized into a QC methodology.
Yeah. And data is kind of useless if it's not being used for something.
Yeah.
So this is also a great juncture where like dashboards for like reporting quality metrics are being built out.
Yep.
And you're figuring out like, are these processes in control?
Mm-hmm.
Are uptimes correct for these stations?
Yep.
There's a lot of data worth capturing here.
Right.
Is assembly being done at the pace you expected? Stuff like that.
Yeah. And what's your pass rate? Because if, the first day on the line, if 13% of machines pass, you got some problems. That's not that machine ain't working. 13% is not enough. So it's like, okay. And that's why it's important to have these things, because every day on the line, you can look at your metrics and be like, oh, wow, we only passed 13% of our machines.
I've had days like that.
Yep. I remember a couple here.
Yeah.
But, that's so important, because if you don't have that metric, you might just be like, I guess this is just what it is. Wow, we have a lot of rework. You need to track that. Oh my gosh, 13% passed? That sucks. Mm-hmm. We need to address this. So like, that's why it's nice to have those kinds of things.
Most definitely.
Yeah, yield. Yield is the word for it.
As an outcome of production validation and testing, the goal is to have a fully validated process that just makes a product completely ready for mass manufacturing. All responsible people have signed off. Everyone feels okay. Mm-hmm. The CM, if you have one, feels competent and ready to make something.
Yep.
Everything's been checked over and everyone feels ready for product launch to be as smooth as it can possibly be. The supply chain's been like completely validated and vetted. People are ready to keep delivering the same material of equivalent quality to the production line. The supplier knows the quality metrics that are needed for production units. Mm-hmm. The production line knows how to ensure that those components in the supply chain are
Correct.
Meeting the quality standards required to make a good unit. Quality is managed in and out in all capacity.
Yep. You're ready to just turn on the faucet. The whole system is plumbed. You have everything where it needs to be. Everyone knows what they need to do. You just need to say, yes, more parts, please. And the system's there to facilitate it.
It's a great spot to be.
Yep.
If you've gone through these 3 phases, you should feel very ready to start mass production, MP.
Yep. And now you have machines. I mean, ideally, this is now the first time you have a machine that's like theoretically customer saleable that you may not sell. Like, we never sold PVT units, but like we kept them for internal use. We kept them for, honestly, I think they're great for marketing purposes. Mm-hmm. That's when, although that's a little late, when you get your first PVT unit off the line to finally have something that's ready for your marketing team to like take a picture of to put on the website, that's cutting it a little close. It'd be nice to do it a little earlier. So like, I think for some things, it's nice to have a DVT unit. For some stuff, maybe the launch video uses DVT, but then PVT is like the documentation, because there it needs to be really close parity with reality with what people actually get. You want to be at like the very last Lumen we built before we started building them on the line is what we use for docs. Mm-hmm. We waited till the very last minute, so it was as close as humanly possible to what people would get. That's nice for that purpose, but
you'd be surprised what people get tripped out over.
Yes. Yeah. Like to have certain, pictures look exactly the same and be as close as you can. That's nice. So you finally get this here. A lot of people are, right at the starting line waiting for that unit to come off, and then they can go and do what they need to do. But, depending on what you need, figuring out the firmware flashing process, that could be done at EVT. That can happen way earlier back. So, however much you can spread a lot of these things out as you go through the process. Some of this just got unblocked here with PVT.
And there's a little bit of stuff that'll feel like chicken or the egg. I remember for Form Labs, we didn't feel comfortable signing off on the package before a PVT unit had been drop tested in the packaging we designed.
Right. Yeah. Yeah.
It was like, oh, this thing's built with tooled parts and tooled processes and production torque specs. And now we have to make sure it still drops the same. So there, at the end of PVT, there are still some gut checks to do thereafter, like making sure you still meet the PRD. Yeah. Making sure that box gets something to someone safely. You're not, ideally, you can just go straight to mass production and say more of that, please. But like with sufficient product complexity, you might need to make sure your I's are dotted and those T's are crossed.
You bet your butt you're running some prints, you're picking some parts on that first machine off the line, you're making sure it works still.
Yeah.
You're running your validation tests on every one of those things. You got to make sure it's good. And that's just what maybe you do for every unit. But like you said, you got to check all the other things. You know, you're running your full validation suite of testing all over again, doing your drop testing. Like something could have changed in PVT at the factory you don't know about yet.
Like it's even worth saying too that this touches on getting into mass production. But I remember at one company I was at, we would have the product leave the factory and we'd compare the outgoing quality control check to the incoming quality control check of like a third party like reviewer.
Oh, interesting.
So like everyone the box would be shipped. The factory would say meets this checklist of criteria and go to a third party house where it would be reviewed for that same stuff. And we'd just make sure like, is the line outputting what we expected? Is the product clean? Is the packaging tape nice? Like, is the sheet metal free of powder coat damage?
Sure.
Like the factory said yes. Third party reviewer said good to go.
Cool. That's interesting.
So we just presented EVT, DVT, PVT in the framework for like a team of more than one person.
Yes.
Possibly even of a CM.
Yes. Big scale, normal, what they say on how to do this in the engineering textbooks.
Yeah. I to hedge it all, I'd say pick out from that what you found useful.
Yeah.
You don't need to be Apple. You don't need to feel guilty for not being Apple about it.
Yeah.
And I thought it'd just be fun to like explain how we did it because it's quite different than this like gated exit and acceptance criteria. Like it can be more chill.
Yeah.
This is a framework to pick out what you want. Don't be militant about it. And
Exactly.
Like, the feeders are a great example of that.
Yeah. The feeders are a good example, especially because the Lumen is like, we iterate so frequently. Like we're always cutting a new release of the machine. V4 was a big launch and that was more of a structured thing. And we still roughly had builds kind of like this, but we know the product, right? Feeders were an NPI. This was a new version. So we tried it out for this and we were so far away from everything that we just outlined. Not at all was how we did it. There were effectively a bunch of what based on the format we just outlined, a lot of engineering prototypes that I made over the course of a few years. And then I was like, okay, we really need to ship a feeder now. I made what really should be called an engineering prototype was our EVT. Like it was a motor that was not what we would ultimately ship, even close to it, because we needed a custom thing made. So I was using an off the shelf thing that I'd modified. The PCB did not fit in the print we used to test this. So it was hanging off. Yeah. It was roughly the right shape, but like it was connected on, a clamp to my desk. Like it was not nice. But it worked. Like I had a test set up and it could feed parts accurately. And I'm like, okay, this has legs. In reality, that's what you'd call a prototype. That's what we call our EVT because we don't need that much granularity. It's like, cool, I know I can turn this thing into something that works really well. Then our DVT it all came together into one nice, neat unit. And it truly did look like it. Maybe really the big difference is that our EVT was a prototype. Yeah. And then maybe our DVT was kind of a mix of engineering and design validation testing, EVT and DVT together. Because that one, it was a works like and a looks like prototype. It did look very close to what we were going to ship. And this is the time where I went to our quote unquote CM and I said, hey, Lucian, what should we do to make this not be a huge pain in the ass to build? And you said, well, buddy, let me tell you. And then we went through and we changed a bunch of stuff and I took a pass at it. But this is really where you were like, okay, this is kind of going to suck.
Does anything stand out to you? I forget what I said. You have a good memory for this type of stuff.
A lot of these things are things that we ultimately fix down the road as well. I had so many press-in hex nuts that you nuked from orbit as you should have. Like ultimately some of those made them into mass production because it didn't matter that much for just we wanted to ship and like we can optimize that out later. Even if it's a little tough to do it. It's so easy for us to iterate. We didn't mind shipping with that for a while. But yeah, you definitely had a few things you're like, this sucks. Oh, huge cutting out in the frame for cables to have more wiggle room.
Oh, yeah.
Huge one. I was like, it's not that bad. And you're like, this sucks. We need so much more space in here. This is
Every time he's not looking, I make the cable pockets bigger.
Yeah, and it's always better. So those things happened. And so that was our DVT. And like, that was like, okay, we understand that it roughly will fit the shape. It was kind of a pain to build. But like, this is where I'm taking pictures. I'm starting to write OHI, assembly instructions internally for this kind of thing. And this is also where we ran most of our lifetime invalidation tests, because our EVT, quote unquote, was just a bunch of wires hanging off a thing to make sure it would hit our spec. Does this theoretically hit our spec? Yes. Cool. This has legs. We'll go forward from here. So our DVT was really an EVT unit. It really is what it is. And then once we had that, we ran a lot of lifetime tests on it. And, you know, we checked to see how many cycles it could feed and peel and all that kind of thing. Again, we did this with DVT, probably would have been EVT at a larger company, but we can compress these things together. And then we did a PVT run. So we know that the design works well. We know it's validated. It has the lifetime. Then we made, do you remember how many we made? We made like 50 PVT units.
We needed 50 for the launch video. So surely
we did. We made at least 50 for the launch video. And so we made a bunch. Again, nice to do them on the Lumen. Each one of these passes, we could just crank through a bunch of different iterations really quickly. And like from start to end, I think it was 5 months. It was like not that long because we started it in fall 2021 and we shipped March 2022. So it was like 6 months at most.
Sounds about right.
The whole process. It was fast. Like we cranked through it because we could.
Yeah.
We iterated really quickly. We had a bunch of different, and I had learned a lot from a lot of prototypes prior. So we were able to do it really quick because we were able to do that iteration.
Yeah, it was good.
But then we did our PVT build. We had our lifetime testing run on our DVTs. We had all our PVT units. We tried making them. I made some, but I think some of the folks on our line made some as well, which was.
We'd written out OHI too.
We had OHI for PVT?
I believe so, yeah.
We must have. I can't imagine you would have let me not do that. We must have done that.
We can check the Git commit.
And also for PVT, we had Gundam, which is our internal test software suite. We had Gundam set up for feeders. So it was checking accuracy for every feeder we ship. And it was going through that whole process. And we had all that script written. And that was the same kind of script that I used for validating early on. But now we had kind of distilled it down into a tool that could be used on the line. And we made those units, and we literally still run some of those feeders on our SMT production line to this day, which is kind of rad.
That's always funny to remember.
It is. It's funny to take a feeder off and there's a PVT label on it. It's like, wow, that's nuts. So we kind of compressed a couple things together because we don't need such formality. We are here building these things on the line. If things are a little trickier to manufacture when we start, that's okay because we can really iterate through. Our molding costs are literally non-existent because we 3D print all this stuff. So we were able to compress a lot of it together and, you know, change a couple things about how they're structured.
The stakes are much lower when there's not like multi-million-dollar contracts with CMs and abroad or $100,000 injection molding tools left and right.
Exactly. We could literally be at the point where we're 2 weeks before launch and we could be like, oh my gosh, showstopper problem. And it's fine. We just don't launch and we stop and we go back and we fix it. You know what I mean?
Yeah.
It's like there's no real momentum aside from in our brains. Like there's no contract. There's no, aside from buying parts or whatever, but like that's the thing we validate the most heavily before we invest all the money in. We know that those are going to be okay. It's going to be a show-stopping design issue that I can just fix and then we're okay, you know? So like that's what lets you do it pretty quickly. And that's why we like doing it the way that we do, where there isn't all this crazy structure around being able to just figure something out and ship it. You know, it's nice to have this in between, as we've kind of been calling it, mid-scale method, where you kind of do it yourself. And then you can choose to scale up and out of that method if you want, after you've validated the heck out of the thing, you know, kind of cool.
I'd say we still followed the framework. It's just very compacted.
Yeah, it was a compacted way, I think. I think that's a good way to say it. I made prototype and EVT merge together a little bit. I made EVT and DVT merge together a little bit. And then honestly, when it came to you and you coming in, then the structure got back on the rails.
You're giving me too much credit, bud.
That's what it was. Like our DVT was pretty much a DVT. And our PVT was pretty much a PVT. Yeah. So like I think you really helped us stay on track.
I felt like the 3-letter acronym started when I got involved, and I was just letting the engineer like play with prototyping before then.
Yeah. We just kind of were doing whatever made sense there. But yeah, so you pick from this what you want. This is meant to serve you. You don't have to follow this religiously like we didn't.
Again, no company does this the same.
Yeah. Yep.
But it's important to be aware of like the ideas of it and you know generally what this is, and it's well presented here.
Yep. Yeah, I think so.
And for anything we use for research, we cite our sources down in the show notes, so go ahead and check there. All right, folks, that's it for this one. Thank you so much for listening. Don't forget to leave a review wherever you get your podcasts. It helps us out a ton. You can learn more about Opulo at opulo.io, as well as YouTube, Twitter, Instagram, and Blue Sky. You can email us at podcast@opulo.io with questions or comments on the episode. To keep up to date with the podcast and Opulo, sign up for our newsletter where we write blog posts and conduct customer interviews with other folks building open hardware. That's it, and we'll see you in the next one.
Thanks, everybody.
See ya.
Touch grass.
Look on the horizon.
Look at both things I don't do enough. If you're nerdy about manufacturing open hardware,
Steven forgot what grass feels
you
like.
should probably take a walk at lunch every once in a while.
Introspect.
I haven't done that in 10 years.
You went to Taco Town with me the other day, but you're very food motivated.
But you had to bully me to go do it.
Yeah, we need to put it on the calendar.
If it's on the calendar, I do it.
Okay, Taco Tuesday.
That's actually pretty good. We should do that.